Welcome back to Rice.AI Code Room. Today we are tackling LeetCode 3740, minimum distance between three equal elements I. Let's begin by explicitly explaining the problem statement. We are given an array of integers, and we need to find three distinct indices that contain the same value. This is called a good tuple. The distance of this tuple is defined as the sum of the absolute differences between the three indices. Our goal is to find the minimum possible distance. For example, if we have the array 1, 2, 1, 1, 3, we can pick the elements at indices 0, 2, and 3, which are all 1. The distance is 2 plus 1 plus 3, which equals 6. Now for the thought process. If we assume the indices are sorted such that I is less than j, and j is less than k, we can simplify the absolute distance formula. It simplifies to j minus I, plus k minus j, plus k minus I. This elegantly collapses to 2 times the quantity k minus I. So, the distance solely depends on the maximum and minimum indices of the triplet. To minimize this distance, we should only consider adjacent triplets of identical values. In other words, we map each value to a list of its indices, and then check every sliding window of 3 consecutive indices. Let's dive into the implementation. First, we use a C++ unordered map to group the indices by their corresponding values in the array. We iterate through the array and append the current index to the vector associated with the current value. Since we process the array from left to right, the lists of indices will naturally be sorted in ascending order. Next, we initialize our minimum distance to -1. We then iterate over every value in our hash map. For any value that appears at least 3 times, we loop through its indices. Since we only care about minimizing the gap, we check every 3 consecutive occurrences, which are at positions I and I plus 2. We calculate the distance as 2 times the difference between these two positions, and update our overall minimum distance. Finally, we return the result. To wrap up, let's discuss the complexity. The time complexity is O of n, because we traverse the array once to build the map, and the total number of inner loop iterations across all values is bounded by n. The space complexity is also O of n, as we allocate vectors to store the array indices. Thank you for watching.